Hi, my name is Nurul Natasha Najwa binti Muhammad Zahari and my number matric is E248325. And I'm going to explain about the introduction. So the first one is the background of the study. Geohazards are natural geological phenomena such as landslides, soil erosion, ground subsidence, and slope failures that can pose serious risks to human life, infrastructure, and the environment. In fact, these hazards are widely recognized as a major environmental challenge, particularly in developing regions. In the context of Malaysia, the frequency of geohazards has been increasing over the years. This trend is largely driven by a rapid urbanization, land clearing activities, and the impacts of climate change, all of which contribute to soil instability. As a result, soil condition becomes a critical factor in determining slope stability and geohazards occurrence. Therefore, this study focused on soil quality as the dependent variable, while bark density, water volume, and soil moisture are selected as the independent variables. In this study, soil quality refers to the ability of soil to support biological productivity, maintain environmental balance, and ensure the structural stability. To analyze this relationship in a systematic way, SPSS software are applied. Next, the objectives of this study are closely linked and structured to achieve a comprehensive analysis. First, the study aims to examine the relationship between soil quality and selected soil condition factors, which is bark density, water volume, and soil moisture. Secondly, the study seeks to identify the most significant factor influencing soil quality. Furthermore, the third objective is to evaluate the contribution of each soil condition factor towards the variation in soil quality. Other than that, this study is significant for several reasons. Firstly, it enhances the understanding of how soil property influence the geohazard occurrence and ground stability. By identifying the key soil condition factors, it provides insight into the mechanism that affect soil behavior. However, this study has several limitations that should be acknowledged. Firstly, the sample size is relatively small, with only 20 observations. Therefore, this may limit the statistical power of the analysis and reduce the generalizability of the findings. Secondly, the dataset used in this study is simplified and may not fully represent the real field conditions, where soil properties are highly variable depending on location, climate, and environmental factors.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Najwa binti Adnan. My matric number is E248322 and I am from course Geoscience. Today I will present about the methodology. For this study, we use a statistical approach to investigate the soil condition factor that influence soil quality and their potential relationship with geohazard. A total of 2 soil samples were analyzed involving 4 variables. The first is soil quality, soil density, water volume, and soil moisture. In this study, soil quality was treated as the dependent variable, while bark density, water volume, and soil moisture were the independent variable. The data were analyzed using the statistical package for the social science SPSS. SPSS was used to organize the data, generate graph and chart, and examine the relationship between the variables. The result of the graph you can see on the result, on the part result, and to determine which factor has the greatest influence on soil quality, we also apply multiple linear regressions (MLR) analysis. This method allows us to evaluate the combined effect of soil density, water volume, and soil moisture on soil quality and identify the most significant contributing factor. Why present soil quality? The regression coefficient and represent the error term. The variable x1, x2, and x3 represent soil density, water volume, and soil moisture respectively. Through this analyzing, we were able to assess how each soil condition factor contribute to variation in soil quality and identify the most pollutions affecting soil stability. Soil soil stability. That's all for me. Thank you.
First of all, we are looking at the dataset table. As shown in our SPSS data view window, we have compiled 20 distinct spatial observations across a hazard-prone hill slope area. So variables B, C, and D capture a critical geotechnical and hydrological characteristic which are testing against variable A, which is our soil stability quality index. This is used to evaluate the potential landslide risk.
Next, to visual our hazard marker, we generate a scatter plot of soil stability quality against soil moisturized. Okay, so here we can notice the steep, which is negative linear trend line. As soil moisturized, percentage will increase on the x-axis. Meanwhile, in y-axis, it will show stability structure that drop sharply. This proves a clear visual evidence that water saturation is actively destabilizing the slope, which is creating a high risk zone for the slope failure.
Now we look at our descriptive statistics. So our dependent stability index shows an average baseline of 3.46. However, looking at bulk density, we see a wide range stretching from a minimum of 70 up to 150 kilograms per cubic meter. So this high standard deviation of 23.65 tells us that our site has a dangerous mix of highly compacted layers and weak loose soil pockets that are highly vulnerable to piping erosion.
So for our first output is about the percent correlation matrix that confirm this geohazard dynamics with extreme statistical significance, which is P less than 0.001. So for the bulk density, shares a very powerful positive correlations of 0.978 with soil stability. Conversely, soil moisturized shares a massive negative correlation of negative 0.956. This calculation proves that as the water displaces air in the soil, correlation drops and directly increases the geohazard level.
Now we can see that our multiple linear regression model shows an exceptional predictive performance. So the R-square value is 0.983, which proves that 98.3% of the variance in slope stability is explained by our density and hydrologic indicators. Furthermore, our ANOVA table shows a significance value of our density, which is rho is bigger than 0.05. So this tells us that our model is highly reliable for engineering teams forecasting real-world landslide triggers.
So here is our predictive hazard equation using our unstandardized B coefficients. Our constant is 7.962, but notice the heavy negative weight of soil moisturized at negative 0.309. This means for every 1% increase in water retention, our stability index will drop significantly by 0.309 units. For the bulk density, will remain our most significant positive protection against failure, which is P equal to 0.001. So our model is valid by this residual historical, which is here showing a very normal distribution around 0.
Finally, we apply our model to predict the stability condition at a critical slope cross-section where bulk density measures 112. So holding water volume and moisture steady at their field average, our equation yields a final stability index score of 3.50. This quantitative forecasting allows spatial analysts to identify exact safety threshold, which give land managers a mathematical tool to mitigate geohazards before structural failure occurs.
Hi everyone. So today I'll be talking about my part, which is discussion. So based on the descriptive statistics analysis, the mean soil quality index was 3.465, indicating moderate soil equality. Moderate soil quality across the sample locations. The average bulk density was about 114 kilogram per meter. So the average water volume was about 518.5 milliliter, and the average soil moisture content was about 22.14%. The relatively low standard deviation values suggest that the data are fairly consistent and do not show extreme variations among samples. So from the dataset, it can be observed that the soil quality generally increases as bulk density and water volume increase. This suggests that soil with better compaction and greater water retention capacity tend to exhibit higher soil quality. On the other hand, soil moisture shows a negative relationship with soil quality, where higher moisturized content is associated with lower soil quality values. Uh, Besides that, this trend can be explained by the fact that excessive soil moisture can reduce soil strength and increase pore water pressure, making the soil more vulnerable to instability and geohazards such as landslides. Therefore, while adequate water is important for maintaining soil condition, excessive moisture can have adverse effects on soil stability. So, to continue with that, we'll slide down a little bit and we can read that the regression analysis was conducted to determine the contribution of each soil factor to soil quality. The results may indicate that bulk density, water volume, and soil moisture collectively influence soil quality, with some factors having a stronger effect than others. Uh, and to conclude everything, in conclusion, what I could tell is the findings demonstrate that soil condition factors are closely related to soil quality. Understanding this relationship is important for assessing ground stability and supporting geohazard risk management, particularly in areas that are susceptible to slope failure and slope erosion. That's all for me for my part. Thank you.
To conclude, the study demonstrates that soil properties play an important role in influencing geohazard occurrences. Factors such as soil moisture, permeability, and soil strength can affect ground stability and increase the risk of hazards like landslide, erosion, and ground failure. So the findings highlight the importance of evaluating soil conditions is to identify potential risks and support safer land use planning. Overall, this study improved our understanding of the relationship between soil characteristics and geohazard susceptibility. Based on the findings, it is recommended that detailed soil investigations be conducted before construction or development activities. So proper drainage system should also be implemented to reduce soil saturation and improve stability. In addition, regular monitoring of geohazard-prone areas is important, especially during periods of heavy rainfall. Future research should include larger data sets and additional factors such as rainfall and land use changes to improve the accuracy of geohazard assessment. Thank you.